Krill server was born on a Raspberry Pi. So far I've shown you swarms on a screen. Now let's run one on the real thing and let it reach out and touch some hardware. This server in the center of the screen is a Raspberry Pi on the shelf, and the app just found it on the network. Empty swarm, real hardware underneath. First a switch, a data point set to digital. On the canvas it's a toggle, right now off. And a second switch, B, 2 inputs, both off. Then a logic gate, an AND, hung under the first switch. It watches its inputs and fires only when both are on. Now the piece you only get on a Pi, a GPIO pin. I'll add it unconfigured. It isn't bound to any physical pin yet, so on the canvas it's just a little Raspberry waiting for a home. Let's open it up. The editor says so plainly. This pin isn't configured yet. Under Settings, Krill draws the actual Raspberry Pi header, every pin on the board, laid out just like the 40-pin strip on the real thing. I'll pick GPIO 17, physical pin 11 on the header. That's the line the signal rides out to the world. Save it, and the pin is real, bound to the hardware, ready to switch 3.3 volts on that wire to light an LED or trip a relay. Here's the Krill part. Nodes are not event-driven. They observe other nodes, even on other servers, and execute when the observed node completes its work. I tell each node what to watch, and the behavior falls out of the connections. The AND gate sources both switches, A and B. And the pin sources the gate. Watch the connection arcs light up. The pin is now observing the gate's result, and it'll drive itself high or low to match. No code, no loop, no controller, just observers wired into a little tree. Let's get in close, turn it on, and start flipping switches. Switch A on. One input is high, but the AND stays dark, and so does the pin. It needs both. Now B on too. Both are high, the gate fires, and the pin goes high with it. On the board, that's 3.3 volts on pin 17. The LED comes on in real time. Drop A back to off and the gate lets go. The pin falls to 0 volts, the LED goes out. The switches are on screen. The voltage is on the wire. That's the whole bridge. A toggle on screen to a pin on the metal with logic in between and no code anywhere. A button on another pin can feed the same swarm. A sensor can gate a relay. The GPIO pin is where Krill meets the physical world.